Hi students, welcome to Math4U. Today we are discussing about the chapter real numbers from class 10. So in this chapter we will be covering prime factorization, LCM and HCF, word problems related to LCM and HCF, and irrational numbers. So first we are dealing with the prime factorization. For this we should know what are prime numbers, right? So let's go ahead. Prime numbers are natural numbers that are divisible by only 1 and the number itself. Only 1 and the number itself. So now let's see some example for prime numbers. You can see here 2, 3, 5, 7, 11, 13, etc. is given. So why we have taken these numbers? Let's see an example. 7. 7, if we are taking the factors are 1 and 7, or it can be divisible by only 1 and 7, right? So such type of numbers are called prime numbers. When we are moving with composite numbers it is given, it is just opposite of prime numbers. What does it mean? This can have more than two numbers as factors, right? More than two numbers. So you can see here example 6 is given as an example, right? For the number 6 we can see there can be more factors, or it can be divisible by 1, 2, 3, and even by 6. Clear? So this is the difference between prime numbers and composite numbers. Once you know about this prime numbers very clearly, it is very easy for you to find out the prime factorization method, to learn the prime factorization method. So once we have done with this numbers, prime numbers and composite numbers, it is very easy for you to do the prime factorization. Okay, so let's see the prime factorization of some numbers. So first one, 60, 84, 108. Let's see the prime factorization of these numbers. So first let's do for 60. We will take the prime numbers. Is 2 a prime number? Yes. 230 times is 60. 2. How you will do the prime factorization like this? You can see 2. You can see 2 one time only in third 3. So there is one here, and the 0 we will add. This will become 10. So 2 5s are 10. 2 you cannot do in this, right? So we will take 3. 3 how many times that is direct? You can say 5. 5 once. So the factors you can write here. The factors are 2, 2, 3, and 5. So next we see 84. 84 2 times. 2 4s are 8. 2 2s are 4. 2 4s are 8. 2 2s are 4. Okay. Next is 42. So 42 how can we do? 42 2 times. 2 2s are 4. 2 1s are. Is it possible for we to do with 2 again? No. So let's go with 7. 7 3s are 21. 7 1s are 7. So you got 84. The factors as 2 square here. Then 3 7. So next number is 108. Let's see 108. 108. So you can divide it with the 2. 2 times which number you should multiply? 54. Then again 2, or then again which number can be 2? 2 how many times? 2 times 4. 1 is left over. 1 14 will come here. 2 7s are 14. So is it possible for 2 again? No. So let's go with 3. 3 9s are 27. So again 3 3s are 9. 3 times 1, right? So 108, can we write it as 2 into 2 into 3 into 3 into 3? So the factors we can see here, these are the numbers you are getting, right? So this is how we can do the prime factorization. So let's see another one question, second one. 504 and 735. Two numbers I have given. 504. How can we do the prime factorization of 504? So either you can divide 50 by 2 and see whether it is possible. If not, you can try with 3. Like that is what how we will do the prime factorization, right? So 504 we can take 2 times. 2 2s are 4. 1. So this is 5. 1 is pending. So we can take it as 10. 2 5s are 10. Then 2 2s are 4 again, right? So next again, if you are taking 2, 2 1s are 2 here. 2 into 2 is 4 only, so 1 is left over for this one, so this will become 12, and this is 2 6 are 12. Is that clear? 2 6 are 12 because 1 is not going in that, so 2 6 times 12, 2 3s are 6. Then again, is it possible with the 2? No. So let's take 3, 3 2 times and 1 time, right? 3 7s are 21, so 3 7 again, then 7 times 1. Okay, so 504, the factors are 2 into 2 into 2 into 3 into 3. When you multiply all these, what you will get? 504. 735, the factors, prime factorization, let's do for 735. I'm going to do it here, 735. You can see 3 times when you are dividing 735 with 3, you will get 245. Or reverse process, when you are multiplying 245 with 3, you will get what? 735. So 5 times again, 49, 7 sevens are 7 times 1. So the factors are 3, 5 and 7, 7, 2 times 7. So this is how you can do the prime factorization. Is that clear? So let's go ahead with how to find out the LCM and HCF. Once you are done with what are prime numbers, how can we do the factorization, prime factorization, then it will be easy for you to learn this LCM and HCF. This is what we have got from here, these numbers. Okay, so now we are going to check how can we do the LCM and HCF. So here the LCM of 60, 84 and 108 we are going to find out now. LCM means what? Least common multiple. So in this we will write all the factors what we got here. That means 2 we got here, multiplied with 3 we got here, 5 we got here and 7 also we got. Once we have taken all the factors, all the prime factors, different types what we got here, we wrote it in multiplication form, and then what we will do, we will check for, this is least common multiple, but we will go for highest power of each numbers which we have chosen. So here you can see we have chosen 2, but the powers are same, so we will take the same. Okay, and we have chosen here 3, and but the highest power is what? 3, 3 raised to 3, so I'm writing here 3. 5 we have only 1, 7 also 1. So we got 2 square multiplied with 3 cube multiplied with 5 raised to 1 multiplied with 7 raised to 1, and when we multiply all these together we will get 3780. This is the answer. How to find out the LCM? Now let's see how can we find out the HCF of these numbers 60, 84 and 108. Okay, so now what we will do for this means we will be taking the common factor. The name itself asking for highest common factor. So what is the common factor here? We will check first. So this is the common factor. One we have is 2, then multiplied with, is there any other common factor we have? Yes, we have 3. Okay, I'm writing 3 also, and we have to check for the least power. For HCF, we will look for the least power. Okay, HCF, we will look for least power. So for HCF, we will look for least power. For LCM, what we will look for? Highest power. That is the difference between these two. Okay, so we will have 2, the least power we have again 2 square only, the same power we got for all the 3 numbers, right? But when you're coming towards 3, 3 raised to 1 here, 3 raised to 1 here, but the last one 3 cube. So the least one is 3 raised to 1. Least is 3 raised to 1. So 2 square multiplied with 3 raised to 1. 4 into 3 is 12. So the HCF of these numbers is 12. Clear? So now let's go ahead with this one. So we are going to find out the LCM of 504 and 735, and also for the HCF. If you understood, you can try now by yourself and check with the answer what I am going to write here. So LCM means, as I told, 2 then multiplied with 3, 5 and 7, because all the numbers are here and I have written all the numbers. Then which power we have to check for? We have to look for the highest power, because this is the least common multiple. Clear? So the highest power of 2 here is 2 raised to 3. The highest power of 3 here is 3 square, and the highest power 5 is 1, and for 7 is 2, right? Now we are going to multiply all these and you will get 17,640 as the answer for the LCM. Now we are going ahead with finding the HCF. Here, as we know, common factor we have to check. Whether 2 is a common factor? No, because 735 is not having a 2, but we have 3 as a common factor over here. Anything else? Yes, 7 also we have. So 3 and 7 I am writing, and this is the highest common factor, and I have to check for the which power? The least power, right? Just opposite. Highest common factor, we will checking least power. So 3 raised to 1 is the least power and 7 raised to 1 is the least power. So the HCF will be equal to 21. Is that clear, all of you, how to choose the LCM and HCF once you are done with the prime factorization? Now, it is given here another one question. Find the sum of exponents of prime factors in the prime factorization of 196. So first what we have to do? We have to do the prime factorization of 196. So 196, 2, if I'm taking 2 nines are 18, this is 19, so 1 will go towards the 6 and this will become 16, and this is 8, right? Then again can I go with 2? 2 fours are 8, again it will become 18, 2 nines are 18, and you can go directly with the 7 here. So the factors of 196 are 2 here, 2 square, then which is the factor here? 7 square. Find the sum of the exponents of prime factors. Exponents. Here we got the exponents are 2 and 2, right? Therefore, sum of exponents is equal to 2 plus 2, that is equal to 4. This is how you can deal with this type of questions. This is one previously asked board exam question. Next is word problems related to what we have learned on LCM and HCF. First question, an electronic device makes a beep after every 60 seconds. Another device makes a beep after every 62 seconds. They beeped together at 10 a.m. At what time they will beep together at the earliest? So here you can see at the earliest. At the earliest means the least time what they will take, right? So once you have read like this, you should understand this. We are looking for the least time. That means we have to look for LCM. LCM we have to look for. So first we have to interval of beeping together can be find out. Interval of beeping together. This is what we have to find out, right? Together. So this can be find out by taking the LCM of these two numbers 60 and 62. So this is your homework. You have to try to find out the LCM of these two. By the time I will write the factors over here, and once you have done with the calculation, you can check whether you have written it properly. Okay, 2 and 31 are the factors of 62. So now the task is to find out the LCM of 60 and 62. So LCM means for 2 the highest power is 2, for 3 the highest power is 1, for 5 the highest power is 1, and for 31 also the highest power is 1. So now when you multiply all these, you will get it as 1860. And you can see that this is given in what? Seconds, right? This is given in seconds. So the answer what we got is also seconds. So this much seconds will be converted into minutes. So 1860 by 60. So this is equal to 31 minutes. Is that clear? So when it will be together? interval of beeping together will be at 10:31 a.m. How you got 10:31 a.m.? Because you got here 31 only. Because the they beeped together at 10 a.m. is given in the question, right? So after 31 minute it will beep together, we found out. So 10 plus this 31 minutes, 10 hours plus 31 minutes, you will get it as 10:31 a.m. Is that clear? So let's go with the next question. Three pieces of timber, 42 meters, 49 meters, and 63-meter long, have to be divided into planks of same length. What is the greatest possible length of each plank? Always read the question twice before you get into the answer. So you can see here the question is to find out the greatest possible length of each plank. So when we are seeing this greatest, maximum and all, we will go with HCF. Okay, after reading the question carefully. Okay, minimum, least and all, we will go with LCM. So this is asking for the greatest possible length. So obviously you understood now we have to go with HCF, right? So this is a homework for you to do the prime factorization of 42, 49 and 63 and check with what I'm going to write here, the factors. So 42 you will get it as 2 multiplied with 3 multiplied with 7, and for 49 you will get 7 sevens are that you can write directly without doing the prime factorization. 63 is 3 times 3 times 7. Okay. So now as we have discussed prior, we are going to find out the HCF. So how can we write the HCF of 42, 49 and 63? So HCF means the common factor first of all, right? Common factor, you can check for the common factor. What is the common factor here? Is there 2 in 49? No. Not in 63 also. Is there 3 in 49? No. Is there 7 everywhere? Yes. You can see 7 everywhere. So I'm going to take the 7. This is 7 square, right? And these are all 7 raised to 1. And this is the highest common factor. So we should go with the what power? The lowest power, right? So the lowest power here is 7 raised to 1. So the HCF is 7. So what exactly we have to find out? Greatest possible length of each plank. So here HCF you got it as 7. So what is the greatest possible length of each plank? The greatest possible length of each plank will be what? Greatest possible length of each plank will be possible length of each plank will be 7. 7 what is given? 7 meters. Is that clear? So now let's go ahead with the next question. A fruit vendor has 990 apples and 945 oranges. He packs them into baskets. Each basket contains only one of the two fruits but in equal number. Find the number of fruits to be put in each basket in order to have minimum number of baskets. So when you are seeing minimum, maximum, you are clear with the concept what you have to go with. But this is a little tricky question. So you can see here, find the number of fruits to be put in each basket in order to have minimum number of baskets. So let me give an example. You have 20 chocolates with you. Okay, 20 chocolates. And you have uh, some pouch with you. Some 7 pouches are there with you. Okay, you want to put it in this pouch, but you have to take only less number of pouches, very less. Okay, so if you want to put if you want to take very less number of pouches, you will fill maximum chocolate in each pouch, right? So same like that, here we need to take a minimum number of basket. So find the number of fruits. So maximum number of fruits will be put in each basket so that the number of basket can be less number of basket you can use, right? Then what we have to find out now? The maximum number of fruits that can be put in one basket. That means you will be finding out what? Very good. You will be finding out the HCF of these numbers 990 and 945. As before question, the previous question, as like the previous question, you can try for the prime factorization of these numbers first as a homework, and then you can check with your answer you are getting. I'm writing it, and you can write with the, and you can check with the answers I'm going to write over. That is 990. You will get the factors as 2, 3 square, 5 and 11. And for 945, you will get the factors as 3 raised to 3, 5 and 7. Okay, check your answer whether you got it. And how to find out the HCF of these two? HCF of 990 and 945 is equal to, how you will write? You can see here, common factor you have to check whether 2 is here in 940. No, but we have 3 as common, so I wrote 3. We have 5 as common, I wrote 5. So highest common factor means what we will check for the least power, right? Least power. What is the least power? Both having same, so I am taking 3 square over here. And for the next 5, we have 1 only power. 3 square is 9, 9 5s are 45. So how the fruit vendor will put 45 fruits in each basket, so that he have to take only less number of baskets. Is that clear, all of you? This is how you have to think when you get a question. Okay, so now let's go ahead with the next topic. That is, you have seen here written, for any two numbers a and b, we always have a multiplied with a b is equal to product of their LCM and HCF. That means if you have two numbers, okay, the product of the numbers is equal to the product of their LCM and HCF. Okay. So first question, the HCF of two numbers is 27. So let A and B are the numbers. The HCF of A and B is given as 27. So LCM of these two numbers A and B is 162. If one of the number is 54, then let A be 54. We have to find out B. So actually this is like, you have to, here you can see that 54 and B, here also 54 and B, then we can write, right? So how can we find out B? We have A into B is equal to LCM into HCF, right? And we have to find out B from here. So LCM is what is given, 162 multiplied with HCF is 27, divided by what will come, this A. What is this A stands for? The first number. What is the first number again? 54. When you are doing the calculation, what you will get? You will get it as 81. Try to do the calculation fast and check whether you got 81 as the answer. So now let's move on to the next one. Find the LCM and HCF of 90 and 144 using prime factorization method, and then verify your answer. Kindly do this as a homework. Okay. So let's see the next question. Find the ratio of LCM and HCF of the least composite number and the least prime number. This is a previously asked question, and you can check here how can we find out the LCM of these two. So what is the least composite number and least prime number? So can I say that the least prime number is what? Prime number is 2, and the least composite number, which is the least composite number, is 4. Okay, so first we have to find out the LCM of 2 and 4, and we have to find out the HCF of 2 and 4. By the time you have found out, I guess this is 4 and this is equal to 2, right? Now we have to find out ratio, means how you will write LCM of 2 4 divided by what? HCF of 2 4, and you can write it as 4 by 2. And what is 4 by 2?
You can write this as 2 is to 1.
This is how you can do it. This is this question asked previously for a board exam. Okay, So let's see the next question. Two positive integers p and q can be written as p is equal to a square b square, and you can see here q is equal to what? A b q. We have to find out the LCM of p q. So it's so simple, right? LCM means what you will write? All the factors you will write here. A and b are the factors and the highest power. What is the highest power of a here? A square. B is cube. So we can say that a square b cube. Is that clear? So these are the topics which are related to LCM and
So next topic to be covered is rational and irrational numbers. That will be covered in the next video. Thanks for watching. Bye.